Imagine standing waist deep in the ocean when a wave hits your face and sends a mouthful of water straight past your lips. Instantly, your tongue is overwhelmed by salt. Not slightly salty, aggressively salty. Yet the rain falling into that same ocean is fresh, and the rivers feeding it are fresh too. So how did the largest body of water on Earth become filled with enough salt to cover every continent beneath a layer hundreds of feet thick? Let's figure it out right here on Unlogic. Every time rain falls, it begins a slow process of stealing pieces of the land. Rainwater absorbs a small amount of carbon dioxide from the atmosphere, creating a very weak carbonic acid. It is not strong enough to burn your skin, but over thousands and millions of years, it can slowly break down rock. As rain flows across mountains, cliffs, and soil, it releases tiny amounts of dissolved minerals. One of the most important is sodium, a major ingredient in ordinary salt. Streams collect these minerals, rivers carry them downhill, and eventually almost everything reaches the ocean. But table salt needs more than sodium. It also needs chloride. Much of that chloride came from Earth's violent early history. Billions of years ago, volcanoes released huge amounts of gases from inside the planet. These gases entered the atmosphere, mixed with water, and eventually contributed chloride to the forming oceans. When sodium from weathered rocks met chloride in the sea, they formed sodium chloride, the same basic compound you sprinkle over food. This creates an obvious question. If rivers carry salt into the ocean, why do rivers not taste salty? They actually contain dissolved salts and minerals, but in extremely low concentrations. River water keeps moving, so those minerals do not remain in one place for very long. The ocean is different. It is the final destination for most of that water. When sunlight heats the ocean, water escapes through evaporation and rises into the atmosphere to form clouds. But the salt cannot travel with it. Water leaves, salt stays behind. Then rain falls again, wears away more rock, enters another river, and delivers another tiny load of minerals to the sea. One trip adds almost nothing. Repeat that cycle across the entire planet for billions of years, and those invisible traces become an ocean of salt. But the land is not the only source of the ocean's chemistry. Deep beneath the waves, seawater enters cracks in Earth's crust. There, it meets extremely hot rock and begins exchanging chemicals with the seafloor. The heated water releases some minerals, absorbs others, and eventually shoots back into the ocean through hydrothermal vents. These vents are not simply underwater salt dispensers. They behave more like giant chemical refineries, constantly changing which minerals remain dissolved in the sea. So with rivers and the seafloor continually adding material, shouldn't the ocean become saltier every year? Not exactly. The ocean also removes minerals. Marine organisms pull dissolved materials such as calcium from the water to build shells and skeletons. Some minerals react with rock and become trapped in the seabed. Others are left behind when shallow seas evaporate, creating enormous underground salt deposits and bright salt flats. The ocean's salt level has changed throughout Earth's history, but over long geological periods, the system stays relatively balanced. Minerals enter, while other processes slowly remove them. So, the salt in the ocean did not arrive from one source or one ancient event. It is the result of rain dissolving mountains, rivers carrying their remains, volcanoes releasing chemicals, vents reshaping them, and evaporation repeatedly removing the water while leaving the minerals behind. The next time you taste seawater, you are not just tasting salt. You are tasting tiny remains of ancient mountains, chemicals released from the young Earth, and a planetary cycle that has been running for billions of years. This is Unlogic.